My name is Ashish. I'm responsible for product management for the NSX Advanced Load Balancer, formerly known as Avi Networks load balancing product. And the focus today is going to be on security and the set of security capabilities that Avi provides. And I'll talk about 10, maybe max 15 minutes on slides, and then we'll spend 10, 15 minutes on demo, live demo. So let me start off with what is our vision for application security and WAF, right? First of all, it has to be always on and everywhere, which means it has to be not just intrinsic, but available seamlessly with the load balancer. It cannot be a separate product or an appliance. It should be available everywhere, on-prem, cloud, as close to the workload as possible. It should be intelligent, which means it has to have built-in learning and automation capabilities and elasticity, right? It should be able to figure out new attacks, but also respond to them in an automated fashion through learning, and also scale out to absorb the attacks as necessary. And finally, it has to be comprehensive and feature-rich, yet simple. And let's see how these principles are carried over in the way we have designed our solution. But let's start with the problem statement first, right? The web applications are one of the biggest set of breaches that we have seen in the recent past. And you'll be wondering, well, if this is the case, then WAF and any sort of application security should be at the top of everybody's deployment, given not just the breaches, but also the financial impact that this creates. The problem, though, is that 90% of the customers that we have polled said it's too complex, especially the WAF piece is too complex, and so that's why they have not deployed it. It's policy complexity, its lack of visibility, and poor performance and scalability. And this actually prevents a lot of customers from deploying web application firewall specifically. We have had customers who said with the legacy WAF solutions, they have to turn off WAF during the peak season. Why? Because it impacts the traffic performance so negatively that they are not able to meet the revenue numbers because they can't handle that much performance. Well, that's defeating the purpose, right? You need the security most during your business critical periods. So let's look into how we have solved those problems in our solution, and then we'll do a demo. Before we do that, though, let me start at the platform level, because at the end of the day, the WAF and the application security capabilities are built on the same Avi load balancing platform. And one of the key differentiator for us from any of the legacy hardware-based or even other software-based vendors is the architecture. And this is the platform architecture where we have a centralized control plane and a distributed elastic data plane, just like NSX, just like Kubernetes, just like any modern software. The control plane is the brain of the system, single policy repository, REST API endpoint, and really the decision automator. And I'll talk about what that means. The data plane, the service engines, are the actually workhorses. They are the ones doing not just load balancing, so full proxy function, but SSL TLS, DDoS detection and mitigation, web application firewall, rate limiting. All those capabilities are done by the service engines. And most of you should be familiar with the pet versus cattle analogy, right? In this case, the service engines are cattle. They are spun up and spun down on demand. The controller, you configure a policy and then a VIP on the controller spins them up by talking to vCenter or AWS or Azure or whatever the environment you're being in, scales them out, a public cloud-like experience, scales them back in, a self-healing, it's an active deployment. And you never have to manage the service engines themselves. It's managed by the controller. They're multi-cloud. It's a piece of software, not an appliance, which means it can run on a bare metal, VM, containers, on-prem or public cloud, automatically spun up and managed by the controller. Tons of telemetry data, we'll show in a live demo, and built-in automation. And everybody thinks of automation as APIs. Well, that's a given. The key automation is what we call decision automation. So you configure the VIP on the controller. The controller decides, should I spin up another instance? Should I use an existing one? How should I do that? Who should I talk to? Get an IP address, public CFQDN. Automatic learning, that's controller's job. It's a public cloud-like experience. Like, for example, if you go to ELB today, AWS today, you don't tell AWS how big your load balancer it should be or WAF entity it should be, and and when should you scale out or where should you place it. That's infrastructure's job. That's what we do, on-prem or cloud. And as a platform, it's a full-featured universal solution. So layer 4, layer 7 load balancing, GSLB, built-in IPAM and DNS, application analytics, container ingress, and of course, full-featured application security stack, including WAF. And it's a multi-cloud solution, which means it works on-prem, it works in public cloud, it works with any product portfolio. But as part of VMware family, we have deep integrations with various products, including NSX and VMC and Horizon and Tanzu and so on. So it's a truly any application, any cloud, a single universal solution. All right. So with that platform background, let's jump into the core design principles as it applies to security and specifically WAF. So the 3 core design principles, again, the 3 challenges that we saw earlier, right? It is simplified yet comprehensive. So there is automatic learning built in, application-specific policies, built-in top 10 OWASP top 10 signatures, but also they're customizable. Rich visibility and insights are not bolted on, they're built into the product. Because one of the key things about a load balancer also doing WAF is that it's a full proxy, which means TCP, SSL, TLS, and HTTP terminate on the load balancer. That means you have access to all the application traffic. Every critical application that you're protecting, you're going to have a load balancer in front. So you're going to proxy it. And so that gives you tremendous amount of telemetry data, not only from visibility and dashboard point of view, but the controller uses that information in a closed loop fashion to make automated decisions. And we'll see that. And then finally, because it's an active scale out platform, the performance scales horizontally as the traffic grows, whether it's an attack traffic or it's a regular expected traffic. It's an automated auto scaling platform. So let's see how built on top of this underlying platform that has built-in elasticity analytics and of course learning built in and complemented by a live set of live services, we have a full stack of application security. So that includes layer 4 level firewalling rules as a reverse proxy, DDoS detection and protection, IP reputation, SSL TLS, authentication, so SAML and OAuth coming down the pipe soon, followed by the layer 7 level DOS and firewall capabilities, application rate limiting, and the top is web application firewall. So it's a single pass solution. As the traffic comes in, proxied by AVI, traffic passes through the full security pipeline, gets re-encrypted, and onto the application. Before I go further down into the exact WAF processing engine, let me tell you a more holistic view, because at the end of the day, the features are features. How do customers use it? So we've been working with a global payment provider who wanted to build, or who's building, a multi-cloud PCI compliant environment where they have some on-prem data centers, there's some public cloud deployments acting as edge pops, and then the payment clients, as they come in for the payment, the request, they wanted to have a fully secure solution that prevents frauds or credential stuffing and does rate limiting for the clients. They wanted, of course, to be a multi-cloud solution, easy to deploy, fully automated with Ansible Terraform, and they wanted to use this to migrate from a CDN-based security to on-prem. And so we've been working with them with the set of capabilities that I saw earlier, as well as some of the roadmap items that are coming down the line, and it's been an extremely rewarding partnership. So it's good to see that you have a set of capabilities, but it's even more important to see how customers use it as a holistic solution. All right, next couple of slides, and we go to demo. So specifically around WAF, I wanted to talk through the set of security pipelines and how that helps us have a simple yet comprehensive, full visibility and a learning solution. So there are 3 pieces in the data path pipeline: a whitelist, a positive security model with learning, and then signatures for catching the known attacks, complemented by real-time logs and analytics, as well as a live feed of IP reputation in future bot detection, as well as signatures that are customized coming into the platform. Okay, so this is the big picture view. The whitelist is the first stage, and when I say whitelist, there are a couple of use cases for that. One, you can bypass static routes, static paths. So if you're going after images, for example, or if you know that certain content is static, you can create rules, and again, automatically to avoid going from the WAF engine, so to have a more optimized flow. You can also create upload paths sometimes with some rate limits, or creating policies saying how much it should be going through and at what fraction it should be going through. So traffic sampling capabilities, as well as your own vulnerability scans. You deploy an application, you want to constantly do a vulnerability scan to see if there are any application vulnerability. You want to bypass the engine because you want to hit the backend applications to see if there are any vulnerabilities, and then you can use those scan outputs to generate the signatures automatically. So those are the reasons why you deploy whitelist. Then the meat of the WAF engine is the positive security model with learning. And this is where your goal is to identify known good behavior. So you want most of your applications patterns to be recognized by the WAF engine, and then detect that anything that matches an expected pattern should bypass the signature engine and go straight through. Anything doesn't match, then can be either dropped or passed on to the signature engine. And as you constantly learn, as the system constantly learns, this becomes the main component where you prevent zero-day attacks, as well as provides the optimal performance, because you are looking for your baseline and you're looking for what is an expected set of traffic pattern. And the final piece, and by the way, this learning, the learnings are the learning rules are automatically generated, but you can also manually create that, for example, from output of a dash scanner, or an admin can create those as well. And then the final piece is the signature piece. The product comes built in with the core rule set, or OWASP top 10 for the known vulnerabilities, but also you can download automatically through our Pulse services for our known signatures for over 5,000 different applications. So this is the whole engine. So as the traffic comes in, unvalidated traffic comes in, the whitelisted traffic passes through straight to the application. Most of the traffic gets handled at the positive security layer, where the validated traffic goes through. The patterns that have been learned, for example, if you expect username and password to be so let's say password to have an alphanumeric in it, and you see some special characters that are not allowed, those traffic is dropped. And the part that is not been learned yet, and hopefully that's a very small part over time, goes to the signature engine, which then the rest of the traffic, the validated traffic, goes through, and unvalidated traffic is rejected. So this is how, with a three-stage pipeline, is how you reduce false positives, have a very highly performant and scalable solution, and block zero-day attacks. All right, now let's jump right into the demo. What you see here on the screen is the AVI controller dashboard. And this is the UI that's using API under the hood to communicate with the AVI controller. First, let me show you a dashboard before and a few things around the dashboard before I jump into the WAF specific pieces. First thing you should notice is, unlike the legacy appliance solutions, you don't see a list of load balancers or WAF engines here. You see a list of applications. And that's important. That's important because at the end of the day, it's all about the applications. So here I have about 7 applications in my tenant, and I have a multi-tenant environment. I have some color-coded green, some orange, some yellow, and then the color gives a representation of the health of the application. So for example, if I pick up one application, such as AVI Demo VS, the health score is 50. It consists of 4 different components: the performance of the applications, the throughput, the latency, and the HTTP level errors, any resource utilization issues, any anomalies, and any security concerns, including bad SSL ciphers or weak ciphers or bad certificates, or a WAF or a DOS attack. All of those go into the security penalty. I can also look at a slightly different view, and the same application now I can see in a tree view. And this is the infrastructure-centric view, where this application is running active on these 2 service engines, the load balancers. There are 3 pools of servers. These are the backend VMs that this load balancer is load balancing, and every object has an associated health score. So almost everything is fine, except that one of these pool seems to have some performance issues. If I double click into the application itself, the next thing I see is the end-to-end timing dashboard. Of course, we have the throughput and the connections and request rates, but one of the most important dashboard is the end-to-end latency diagram. And because at the end of the day, what matters is how the end consumer of your application is experiencing this app. So here, over the last 6 hours, and I can go back in time as far as I want to, what's the latency on the wire on the WAN side? What's the local network latency? What's the latency on the application side? This is one of the key components. This is the delta between the application receiving the HTTP request and it responding with the HTTP response. And finally, how long it's taking on the wire. So on an average, the end user is experiencing just under 200 milliseconds of latency. But I can go back in time and say, well, this morning, 6 a.m., I had a spike in latency. And that spike was tied to the yellow band, which is the application latency that shot up from what used to be in the 30 millisecond range to 70 millisecond range. And so it's not a network issue, it's an application issue. And this is a key insight. Most of the time, it's the network admins or sometimes it's firewall, the security admins get blamed for any performance issues. Well, clearly in this case, without doing any agents, without a TCP dump or a Wireshark, you know exactly where the problem is. It's the application. You can actually double click into that. So if I click on the log screen next, I have every transaction that's logged. I'm showing you first the significant logs, the logs that we have decided, the system has decided that has some issues with that. So if I open one of them up, it tells you that this specific transaction came from France on what kind of end user device, Windows 7 machine on a Firefox browser, how long this transaction took end to end, and what was the URI, and a bunch of other information. And it was called out as an issue abnormal because the application latency was higher than expected, higher than the baseline, in this case, 97 milliseconds. I can also go down and see what are the different SSL TLS profiles for this traffic that's coming in. What's the breakdown of TLS 1, 1, 1, 1, 2, PFS or not, what type of certificates, RSA or EC, and what are the top ciphers. All of that security information is available at a single click. Now, let's look into some other security capabilities on the dashboard. So I'm going to go into, actually, let me go back to the same application and look into the security dashboard here. Security dashboard tells me what are the different SSL TLS certificates that my application is using. As soon as the screen refreshes for me in the next few seconds. It tells you what is the SSL TLS score of my application and if there is any DOS attack that's going on. Let's see if this refreshes for me. Or maybe I can pick, there you go. Oh, I clicked out too soon. Let me go back to my application and the security tab. There you go. So here it's telling me that what is the breakdown of different certificate types, the TLS version. My SSL score is coming from different components. Here I'm digging the score because there is no trusted CA certificate. Now, let me look at another application where we have simulated a DDoS attack, calling it DDoS victim. So I go back to the security dashboard, and here on the right-hand side on the DDoS screen, you will see in a few seconds the DDoS attack that the system is detecting. So it's seeing both layer 4 level attacks and layer 7 level attacks. And if I go into the DDoS screen, it tells you what the attack types are, the DOS HTTP timeout, as well as SYN flood attacks, where this traffic is coming from, specific IP or AS, and how long it's going on. And at the bottom of the screen, I can actually see what type of attack. So blue is the SYN flood attack, green is the DOS HTTP attack. I can see that. And if I need to block certain attackers, I can just do that with a single click. Again, all of this is available through API as well. All right, let me now come to the last part of the demo, which is the WAF demo. So I just have a different tenant here on the same demo system where I've done the WAF traffic and the WAF learning has been enabled. So this dashboard is identical to what you saw earlier. Again, over the last 6 hours, what is the traffic? I had some traffic running a couple of hours ago. And when I go to the logs, you can see the traffic that has been whitelisted. So you can search for traffic that's been whitelisted. And you'll see that here, this traffic was whitelisted. And you can open this up and you can actually see this traffic is whitelisted right here. So it tells you what was the, it was a path rule that was hit and allows those static paths. And so it was, in this case, a /CSS. You can also look at the traffic that was rejected. So I just click on that and say traffic that was rejected. It tells you exactly why a certain thing was rejected. So let me open this up. And in this case, it tells you, by the way, we also give you latency information in the WAF engine itself to tell you what the performance impact of enabling WAF is. So in this case, a signature was hit. It was a protocol validation error. Specifically, it was the URL extension was in the restricted list. It is a .com in the file list rather. So that is simulating an attack. And then finally, there is one more attack here. In this case, it was a positive security rule that was hit. And in this case, you can see here that this location, the ID, we expected a numeric ID only. And in this case, as you can see, the ID was alphanumeric. So because the system had already learned that this field within the page is expected only with a numerical field, it saw an alphanumerical field, and so it rejected the traffic. Of course, if you think that this is a valid traffic, you can easily create exceptions with a single click. Now, there is a lot more analysis that is given here. It tells you what are the different WAF rules that are getting hit. There are two types of rules, SQL injection and file extension. In fact, I can go to the WAF dashboard as well, and it tells you over the whatever period, what are the different attacks that we are seeing, what are the signature groups that are being hit. So these are the core rule set groups that are being hit. What are the rules that are getting hit? What are the common paths and popular combinations of attack? Again, very, very rich information on the on your WAF attack analysis. Okay, with that, that concludes my demo. So again, thank you for attending the security field day. If you need more information, we highly encourage you to go to avinetworks.com and sign up for a virtual event or a customized demo. Thank you for listening.